Good afternoon. Today I'm going to talk about Elasticsearch in production. Elasticsearch is one of the new kids on the block that not everybody knows. I'd like to show what are the great things about it, but also what were the drawbacks while we're using it. As it is a very new tool, a lot of us, and maybe hopefully a lot of you as well, have downloaded it and played around with it on a Friday night. But there's not that many companies actually using it in production yet, not as much as in solr. So I think it's maybe interesting to hear about what were our lessons learned. So I'm going to talk about a little bit introduction, then a little bit of introduction about Elasticsearch. What is it, especially for people who only have heard maybe about the name, and then talk about where we're using it currently in Udini. It's one of the tools we created last year, and that's making heavy use of Elasticsearch. And there's even a new upcoming tool, of which I'm not allowed to say the name, but it's even greater, I guess, which uses Elasticsearch, so I can show you a little bit of what we're doing there, and then I'll add some lessons learned. So who am I? My name's Anne Veling. I'm from the Netherlands. I'm self-employed contractor, and people always ask me, what do you do? Well, one of my issues is I like too many things, so it's a bit hard for me to say no. So I'm a software architect. I do a lot of process and project management in agile, continuous deployment style things. My previous job was in performance optimization, and I still do that. So I travel around the world where people have crashing Tomcats and Oracle servers dying and memory issues, and I try to solve those things, both technically and on the process level. And I've been involved in the Lucene community since forever, I guess, and I actually help out with implementations, and I give training, custom training in Lucene, solr, and Elasticsearch. So what is this Elasticsearch thing that we're all talking about? It's based on Apache Lucene, and I'm guessing all of you know that. It's the best open source, well, the best search engine in the world, period. Elasticsearch was started in 2010 by Shay Bannon. That's his Twitter name, so follow him if you don't already. It's open source by an Apache license, not under the Apache umbrella, but it is open source. And recently, just this year, just a few months ago, a company was formed called Elasticsearch, with Shay and other committers as well, to do training, support, and also development on that. Similar to what Lucidworks is doing for solr. So that may also help you sell Elasticsearch in a company to say, well, there's actually people, you can hire people, Elasticsearch experts as well. One of the great things I like about Elasticsearch, if you talk about open source community, it's great. There's so many things out there, and open source has become really mature. But one of the pitfalls of us in the open source community is that we build things just because we can. Right? You get a patch submitted by somebody and say, wow, that's really great that you do it. But does it really make sense to add this to the product? And one of the great things I like about Shay is that product development goes slow. Well, he's built this in 2 years, but still very careful. There's not new things added that sort of half work, right? They either work or they don't. And I think that's very special about Elasticsearch. So what is Elasticsearch about? It is designed to be scalable. So it means it has distributed node. It's very distributed. It has node discovery in it. So it automatically can recognize other Elasticsearch nodes and connect to them if you want it to, of course. And they can. So all that discovery part is in there. And one of the things it does automatic sharding. By a very simple way, it has its own identifier and just uses identifier modulo number of shards to determine what shard everything goes in. And just because it does it like that, it can do a lot of very smart things about where to route certain queries, if an update comes, where to put that update to make sure things are local as well. It does query distribution, so you query one node, but it goes to other nodes as well. All of those things you sort of want in this cloud type of world, you get for free in Elasticsearch. It has a RESTful HTTP API with wrappers for any language you can think of. And almost every day a new language wrapper comes out. And one of the things it's all JSON. JSON in, JSON out. But then again, most of our data is JSON already. Our clients are talking JavaScript, JSON. So this comes really handy as well. And the document, it really fits the document model, because the document model uses that JSON structure to map it onto Lucene. It's one of the things that if you're using solr or Lucene natively, you have to do yourself, trying to map a document onto field names. And Elasticsearch does that for you. So if you have a structure with a book and several authors, and each author can have a last name, Elasticsearch will sort of put this thing in a Lucene index for you and on all levels, so you can search on that. All of those things you start doing every time. And just because it has it under control, it can do a lot of nice things. Elasticsearch is schemaless. Well, we've heard that before, right? So yeah, schemaless. In reality, you still need a schema, just like anywhere else. I'll talk about that later. But one of the nice things it does do field type recognition, because a JSON document is structured not just strings. It can recognize, hey, it looks like this is a date. It looks like this is a number, a floating point number. And even if you don't give it a schema, if you give it a field that it hasn't seen before, it tries to be smart about it and think, I think this is what you mean, and this is the index. You can overwrite whatever you want, but it's fairly smart in what it tries to do there. Also what it does, it keeps all the source, so any JSON document you put in, it just stores in a source document. By default, you can switch it off, but by default it does that, and also that, it allows you to do a lot of smart things. And it keeps something like a version number also automatically, so if you update something, it increments an internal version document. Some other great things that Elasticsearch has, it has integrated faceting. It just works really fast using all the caches that are there. It adds statistical aggregates like sum and average and on number fields if you want. And that's very, very powerful. Many of the queries that we want to do actually can be fulfilled by this. It has many different field types, strings, all sort of numerics, even geospatial things, attachments. But also arrays, so arrays of other things, arrays of numbers, arrays of strings, arrays of you can have sub-documents, you can have nested documents, which we've heard today as well. And because it has integrated sharding, it knows a lot about, from an identifier, how to in what shard it should put the document. You can do really smart things with routing and aliases as well. I'll just put it in here, so later when you're checking out in your hotel room tonight, Elasticsearch, you can think there was something about routing. Let's look it up on the documentation. You can do cross-index searching, multi-document types, really clever. You can all of those documents you can put in there. You can say I want to just not just know books, but also books and journal articles that have an author, or everything that has an author. All of those things you get for free. So it's a really flexible tool. Really, it sort of supports the things that we seem to start to expect nowadays. So where do we use it? We use it at udini.proquest.com. I'm a contractor. One of my larger customers is called Proquest. It's a US-based large publisher aggregator, really quite a large one. And what we have created in the past 1.5 years is called Udini. So that's the URL. If you want to, what we are is the world's article store. So we have the largest collection of PDFs that you have to pay for. So if you want to get stuff for free, you use Google. If you want to have stuff and say, well, there's an author who actually wants some money from it, you can search it in Google and then go to Elsevier and go to here and go to there, and then you think, do I really want to give this guy my money? I don't know. We try to aggregate over all of that, and we currently have a really big set from many different sources there. And it was a lot of fun building that. I was in charge, technically in charge of this development team all over the world. We were a virtual team, and it was great building that from scratch. And it's all in the cloud and Amazon. We program in Scala using unfiltered and using MongoDB and Elasticsearch. Let me give you a very high-level architecture overview. So we're using MongoDB to store our stuff, Elasticsearch to allow our users to search locally, and we connect to a different service also owned by Proquest called Summon that I've been involved in before, that is using solr to actually index all those documents. So that's like an API we're calling internally. And then we have a pipeline for PDFs. You can put your own stuff in there, and sort of like a MapReduce tries to get data out of there. And we have many different fulfillment providers, because anything you can search on, you can actually get as well by clicking. And it sounds trivial, but implementing that was quite a lot of work, of course, to getting the PDFs from all the different sources in the right way. So how are we using solr at Udini? Again, this is connecting to the Summon API, another great tool used by libraries all over the world. And that's a really big cluster, about 700 million full-text documents. Last time I checked, I think it was the Lucene index was about 3 terabytes on disk, just the index. So that's really big, enormous Linux cluster of items. And it provides a really nice RESTful API that we can connect to. And in Udini, we serve a subset of that, currently 160 million. There's no store in the world that has more than this. And we include the fulfillment mechanism, and you can actually get the PDF, download, print, whatever you want with it, but also annotate and view online. And we hope to also be sort of like a tool where people actually put their own stuff in, not just from this store, but also from the web and from their own things. So this is where we're using solr. And Elasticsearch is in one part of that, is the local index, because everybody wants also to search on their own stuff, their own, maybe out of the 120 million, I have bought 20 articles, I have bookmarked, I have saved stuff, I have my own articles in there, so a couple of hundred of these documents I have, I want to be able to find them using free text search as well. And we chose Elasticsearch for that last year, and really happy what it is. So it's interesting because there's a lot of documents, but each index is really very small, right? It's only, well, a user having 500 documents, that's actually quite a heavy user. So we would have a lot of different elements and everybody would search in one little part. So how we chose to implement this using Elasticsearch is using the user ID as the sharding key. So every user ID, you know that all the documents from the same user are in the same shard, and every query, we just add that, and it just works. And one of the great things about this is just very horizontally scalable. If after this talk, because all of you are gonna get an account here, did I mention first 5 articles for free? Not yet, right? Then we can really scale horizontally very nicely. So that's Udini. Then we're currently working very busy in the deadlines. You all know that at the end, just before you want to launch, little bugs to fix. An exciting new product, which I'm not allowed to say the name, also for Proquest. We're going to create a great new online tool to help scientific researchers in laboratories and universities and companies actually manage what they are researching. And for that, we are creating a large Elasticsearch index for canonicalization of journal articles. So we're creating from various sources a list of all English language scientific journal articles in the world, making sure we have high quality content to allow people, to give people, to help people enter data, to make sure we all know what is there, so that you don't have to type in all of that data yourself. And that's been a challenge, and also because it's much larger, we're learning a lot about Elasticsearch doing that. We're currently in private beta, and we hope to launch in the coming months. So let's talk about the important things, right? Lessons learned. Well, one of the lessons learned is very fast indexing. I've been using Lucene ever since 2000 or something, and it continues to amaze me how ridiculously fast this is. So we're using bulk indexing, which is a specific Elasticsearch way of bringing a lot of data in. What is important then, you need to set it up without replicas. And initially we said, let's put replicas to 1, but you need to remember you need to set replicas to 0 because 1 actually means 2, let's say 1 extra. To make sure it's fast enough, you can play with the bulk size. And what we chose in the event initially is get the data out of the source system, just write it to disk in text files, JSON files, and just curl them in. Just a command here, you just curl them in. And we do it 100,000 at a time, and it's just so ridiculously fast to get from nothing. So on my MacBook, well, it's SSD, but still, it's 1 million records in 40 seconds. So just getting everything in there and just works. It's like, what? That's great. It sort of allows us to change the mapping file and try it again and again. So it's very fast. It's one of the things we liked. Schemaless, yeah, that's been the promise forever, right? It's been the promise of solr as well in the beginning. So yeah, sure, it's schemaless. It works without a schema. One of the issues, what it does is it does automatic field type recognition. So it can miss types. Like we had the first few documents that we put in, they have things like ISBN and ISSN numbers in them, and they sort of look like dates somehow. So somehow Elasticsearch thought it was a date, and then determined this is a date, and really forced that format on you for the rest, and that's wrong. It just breaks. Well, then you have to specify, sorry, this is a keyword, don't tokenize this, do it like that. So some of those things get in your way, but it's just about trying and see what's going on. And it's very strict about the types. Like we have dates, publication dates, from coming from various sources. And you can imagine they're very dirty. You can have a real nice date, you can have 2000, but sometimes the publication date is literally last summer. Well, that's very hard to actually parse the date out, and it actually changes. But we still want to show that. So we have a flexible date format, and Elasticsearch cannot really handle that. So we had to split that in two to say, well, when we have a date, we do it here, and we have a fuzzy date, we store it a little bit differently. Mapping of subfields, things like doc.title or doc.publication.title, those two things should not really be matched on the same index. And it turned out that we ran into an issue where I locally had a newer version of Elasticsearch than we were running in production that actually supported a bit of smarter way of mapping this. So, of course, tested it locally, works, and then on our integration line, it broke. So in reality, you still need a schema. That's just it. And of course, then that also means that if you have to do a mapping change, if you think of a new something that needs to change, it is still not trivial. You cannot simply do that because you have to re-index everything. So you have to be careful and add some data migration or process around that to make sure that while you're doing that, the system is still useful. So one other things that we learned. Well, one of the key things that I learned here is learn to trust Elasticsearch. And we've run into this more often than not. I know Elasticsearch and Lucene quite well, but not everybody on my team. We've had things where we've run into issues where people are actually implementing their own analyzers and tokenizers or extracting them from Lucene, tokenizing the query and then sending that query to Elasticsearch, and we ran into issues with strange characters and umlauts and whatever the Germans like to use in their words. It turns out that because of this really problematic thing, it's like, why do we need to do that? Why can't Elasticsearch itself do that? And it turns out, sure, of course Elasticsearch does that. You just need to make sure you call it in the right way. And then when we just removed all that code and called Elasticsearch the right way, it just knew, oh, wait a minute, the title or author field, let's do some diacrit analysis or stemming or lowercase, whatever you've done. It does that for yourself. So difference between term and type text queries, one who actually uses analyzes and one who does not. Very important, we ran into that. And well, in general, if you think, that's a bit strange. It would have been quite dumb if Elasticsearch doesn't do that. I have to do that really? Even if you can't find it, start with the assumption it probably does. You just have to find the right configuration. And often, in many cases, I've just thought, well, if I were Shay, where would I have put that little configuration mapping? Let's do /. It's all HTTP, right? /something_ mapping, and there it is, it works. So documentation and findability of documentation and blog posts about how to use the more advanced stuff, that's it's growing, but it can be better. So other lessons learned, we had some issues with automated testing. We're using continuous deployment, deploying to production almost every day, automatically in different build systems. It's all virtual. So our tests are very important. And we have, well, over 1,000 of automated tests running, and they all use Elasticsearch as part of that. And just stopping and starting the Elasticsearch node automatically, even in memory, so many times just takes so much time. So we ran into issues there where this great automatic node discovery actually picked up a previous version in the same VM and sort of connected to that one, and then it dies and gets errors, and it's only intermittent errors, of course. So it's a bit hard. So we had to do some tricks around that. And we had some memory issues where we just had an out of memory exception. So we thought, oh, we have memory on the box. Let's increase it to 8 gig, and then everything died. And it turned out that we didn't know well enough exactly how the memory is managed. So some of the caches in Elasticsearch are actually managed outside of the heap. So that was one of the issues we had a few weeks back. Be careful there. It's doing some magic. So more lessons learned. There's an enormous amount of attention on Elasticsearch. A lot of people are using it. There's great new tools. So if you thought you knew the tools that are there, like Head, which everybody's using right now, something like Luke for Elasticsearch, there's new tools coming out every month. So keep an eye on the blogs, try them out, and there's a lot of great stuff there. One of the things I didn't know in the beginning was to actually wait for the yellow status. It's one of the calls to actually wait until a new node or an index is in a state where you can actually use that. So sometimes under race conditions you can get issues, but you can just wait for that. And using aliases and routing, you can do so much clever things. One of the lessons learned. So the API, Elasticsearch is quite new, right? It's 2 years old. The libraries to connect to it are still in infancy, changing all the time. Documentation is there. It's growing. There's a lot of detailed documentation, but to actually get to that place is not easy. If you search, if you have a bug or a detailed query, you're often one of the first persons in the world to get that. Well, it's a new tool. We had some issues using the Java API in Scala, how we're using it in a more functional programming way, and part of the Java API wasn't really good at doing that, and we ran into some issues there. And then we're currently using Scholastic, and there's the URL by a person who just wrote a little Scala version of the wrapper, which is great for us. Allows to have synchronous, asynchronous methods and bulk methods as well in a really Scala, clean Scala way. So, what could we use, just like the previous talk by Yannick, could you use Elasticsearch as the database, right? We're using Mongo, and next to it Elasticsearch to search part of that data. Many types of the types of queries we're doing on Mongo, actually we could do very well, equally well, maybe even better on Elasticsearch. So this is, I think, a question that becomes more and more as these search products get more mature. This is getting more and more relevant. So yes, you can, in a similar way of what Yannick just explained, using the version that's there, an optimistic logging scheme, you can actually use Elasticsearch as a NoSQL type of data store as well. And that's one of the things, we could have replaced MongoDB there. It's just that we started, well, more than 1.5 years ago. At that moment in time, Elasticsearch was really young, and we just didn't dare to do it, and it's becoming better. Right now, if we would start again, this would definitely be an option for me. Just have one place there, and do not use MongoDB, which is great, but also has its own type of issues. So one of the things I like about using search instead of a database is that search tools like Elasticsearch and solr, they're actually aimed at a store that is optimized of getting things out, right? And relational databases, and also partly Mongo, are much more about how can I best represent the data, how can I most easily put things in, right? And if you want to have a database that you just want to put things in but never get things out, you just put it in a black hole or something, I don't know. But usually your data, you're storing it for a reason, and the reason is usually querying. So I really like the way that you have to sometimes jump through hoops a little bit or tweak your data during indexing time to make sure it's easily searchable. But that's the whole idea of why you have data in the first place. And one of the great things, you get free faceting. And then, well, what it doesn't do is multi-table transactions, like all NoSQL databases. And then that's always what you get back to say, well, I can't throw away my database and put everything in Elasticsearch or solr. But I think you can in many cases. Not every time, for banking not, but for other cases. If you have a multi-table transaction, what I found at customers, when I do consultancy on this, usually when you ask why do you need it, it turns out you're looking in the wrong way in your data, right? So if you need multi-table transactions, you're probably storing information that should be close to each other, far away from each other. And if you can change that model and go more to a document model, often your world, it is a bit of a change of mindset, but it becomes much easier to handle. So in many cases, not all, but many cases, using Elasticsearch or solr as a key store for your data in web applications can be a really good alternative. And then you can use all of the indexing and faceting stuff for free. So of course, one of the important things people always ask me is solr or Elasticsearch. Well, I know both and I like both, but I'm here to talk about Elasticsearch, so I hope I don't stand on too many solr toes here. So solr is well known, has many tools and many extensions. Excellent, great for many years. On the other side, Elasticsearch is the new kid on the block, right? It's new. It's not everything is in there, right? All those detailed, great stuff and analyzers and grouping and faceting that you have for solr, you don't yet have for Elasticsearch, or you have to do some programming yourself. Sure. Still, solr, to me, it feels a bit clunky to configure. It's heavy, it feels heavy, and Elasticsearch very easy to configure on the other hand. And one of the great things about solr is you have to do a manual document to Lucene mapping yourself. You have documents usually nowadays, JSON documents, multi-level documents, and mapping that to specific fields and what you want to do. In solr, you have to map that in the solr config yourself. And Elasticsearch, because it has this assumption where all the input documents are just JSON documents, it can do much more magic, to say, under the hood by itself. So it does all that for you. You just put a JSON document in there, and then you can search on 3 levels deep in that document and get all the greatness of Lucene without you having to worry about, oh yeah, what is this type? Oh, it's a sub-array sub-document. I want to find all blog posts that have a comment, that have a tag, say, bullshit on it or something, right? And all of those things you can actually get without you having to worry about that. In solr, replication and indexing in a cluster is still not trivial. There's a lot of movement there also in the past 2 or 3 years, but it's still not trivial to set that up for a customer, to make sure it works, to make sure it continues to work, especially in a cloud environment. While in Elasticsearch, all of that has been taken into account from the beginning. So it means that some of those things, just because it knows about the sharding, exactly how the sharding is done, it does all of that for you automatically. Easy replication. One of the issues is, one of the great things I said about Elasticsearch is it has a assumption about sharding, using the sharding key modulo the number of shards. But you can imagine what would happen to this model if you want to increase the number of shards, right? So if you have 8 and you say, ooh, I'd love to have 9, right? Getting that from that to the old situation to the new situation would actually require an enormous amount of data to travel from one to another. That's also why Elasticsearch does not support this out of the box. You have to do some programming to get stuff out and in. And if there's a lot of data, that's terrible, right? You can't just split one shard and say, I want this shard to split in 2. So it's one of the benefits of Elasticsearch that it does this. It allows it to do a lot of assumptions and magic for you behind the scenes. But also, it is a drawback. It means that early on, you have to think about, okay, sharding, how many shards do I want? And using very detailed shards and using routing and aliases, you can still have the flexibility of changing some of that, but you have to be careful. If after a year of production, it turns out that one of the shards gets so big it can't fit in one Amazon box, then, well, you're screwed, but you have to actually get the data out and program some stuff and copy it to a new cluster with a new, and it takes a while. Right? So solr, old school, of course, a bit tongue-in-cheek here, but I know a lot of you haven't seen Elasticsearch, and I'm very enthusiastic about it, so I want to encourage you to look into that, and Elasticsearch is new school. So trying to put that in historic perspective, the evolution of search, what happened? Let me give you an overview of time since the beginning of time, which is before Lucene was there. So before Lucene was there, I don't know how many of you were into search from before Lucene was there. I have. We've all been creating our own custom indexes and creating C++ libraries to do inverted file indexing and trying to be smart about it, and it was a great time. But then Lucene came out, and you sort of try that and think, what? This is 1,000 times faster than what I could imagine. It's just the smartest way forward. Great. Search, inverted indexing, that is solved. A new little desktop tool a friend of mine wrote that I said, oh, I'll be your beta tester. I'll ask him later. Okay, so so Lucene solved inverted index, really clever way of doing segment merges, so it can assume things about order, about identifiers, about caching things because it's write once, read many times on a deep level. And then when Lucene came out, the years after that, everybody started to do their own analyzers, their own tokenizers. Everybody started to implement their own faceting engine. I've done that. Great fun. And then because everybody was doing the same thing, solr came out. And it tries to make the best of those worlds. Say, well, faceting, sure, this is how you do faceting. Analyzers for Arabic, sure, this is how you do it. Geospatial things, this is how you do it. And an enormous amount of investment in the community has gone in making solr the great things there. Also, many of the analyzers, it turned out, after we've all done that many times, they're all not that different. They all do the same type of things. You first do this, you tokenize, then you lowercase, you diacrit, you stem, etc. And one of the great things what Solr put into the equation is that you can configure that without having to program it, just XML files. Great. So Solr is out there and it's growing and it's a great tool that I'd recommend to many of my customers. But where are we now? I think a lot of the situation where we are right now, as you see also in the presentations I've seen today, is that a lot of people are working with Solr to make it do certain things. And if you look around the world, a lot of people are doing the exact same thing with Solr and needing to jumping through hoops to do that. What are people always doing now? Document mapping, sub-document queries like joins, making sure the replication works correctly. And there's a lot of different add-ons and tools and new versions of Solr to make that work. In this schema, it looks to me like Elasticsearch is the next evolution of search to say, Solr, nice, thank you for a couple of years of great service. We now know how most people actually want to use it. We want a JSON document input, and then we get the faceting, complex queries, all of that just works. Not because Elasticsearch is much smarter than Solr, no, because it is a different purpose. It assumes certain things about your data, about sharding, about configuration. Because it has a RESTful HTTP interface, it doesn't have to deal with people messing deep down in a class as the configurability that Solr allows. And because of that, it can do certain things for you because it has that under control by itself. And I think that's one of the great things about Elasticsearch. It's new, so yeah, if you want to do really complex geo stuff, sure, keep with Solr. If you want to do Chinese, all sort of strange things, keep with Solr. But as more and more people are moving towards Elasticsearch and making it easier to also to make little plugins to that, I think that Elasticsearch will become a next level of download, install, and it just works for most of what you want to do. Right? So, to conclude, benefits to Elasticsearch, it's very easy to set up. Just download it, it works. It's an HTTP interface on your browser, you can play with it, there's some nice scripts on it. The architecture is very, very clever. Those little assumptions it makes is very cleverly done. One of the drawbacks, it's very new software. Tool support is limited, new stuff is coming on. But there's lots of movement, right? A lot of people are starting to use it, a lot of companies are starting to use it. So it's becoming more and more mature. And one of the other drawbacks is changing the sharding in a full index, as I said before, is not trivial. So it is one of the drawbacks of using Elasticsearch, but it's based on one of the basic assumptions there. So Elasticsearch, it's clever, it's fast, it's very stable, very mature, which is interesting for a very young product like this. We've been using it in production and never had any issues with crashing or things like that because of bugs. And usually, I think it does exactly what you need. So, to conclude, thank you. It's 2012, so I'd really encourage you to get Elasticsearch out there and just play with it and sort of see, okay, interesting. Maybe a next project I can start using that. Okay, thank you. So I believe there's some time for questions if there are. So we're running this in production. So your question is, what sort of hints do we need for monitoring this on production? Yeah. Well, we have a lot of cloud, a lot of Amazon servers there. So we're using server density and ping them, but server density internally and some of our own scripts that we monitor. So we monitor CPU, I/O, specific application-specific things, and we get alerts automatically from that. So mostly, it's about some of the alerts that have proven most useful is CPU utilization over 5 minutes. So when some of our nodes all of a sudden start to go to 90% CPU, not just for a peak, but over 5 minutes, usually something is going on. So we alert ourselves because we're a dev team, and then take action. I guess if you have a sharding that is unbalanced somehow, and you have a user ID key or something, and one of those users is an administrator user, and all of your queries, or half of your queries, are actually going for that user, you can have all of them going into one place. Yes. So if you can have, we didn't have that yet, but choosing your sharding correctly on a identify that doesn't have too much meaning and gives you enough granularity. That's very important indeed. So we haven't run into that, but I'm sure if you make a wrong mistake somewhere, you can get one node that's doing a lot of stuff and other nodes that don't, and then you have to take action to balance that out. You can, but yeah. There are great guys here in the room that know a lot more than me, and thank you again.